Welcome back. In this video, we're going to go further with our study of reaction rates by doing some examples. Let's start with what we ended with the last video, and that's um, a general reaction, the rates of the general reaction. So let's imagine that you have various reactants. I've got here two. You could have any number. I have A and B, and then various products. You could have one or more than one, it doesn't matter. Every one of these reactants and products are going to have a coefficient. It's either going to be one or more than one. And so we're going to find that the rate of each of these going away or being produced is going to be equal to 1 over the coefficient from the balanced equation times the concentration. So as the concentration is building, how fast is it building? It's building as a fraction, the coefficient of the fraction as the denominator, coefficient as the denominator in a fraction times the concentration. So no matter what it is, they're related to each other. Now we don't know how fast the whole reaction is going to happen, slow or fast, but we do know related to each other inside the reaction. As one goes away, the other one is being made. So here's an example. Ozone gas breaks down into oxygen by the following reaction. 2 moles of ozone breaks apart into 3 moles of breathable oxygen. Okay, so they're going to give you the reaction rate or how fast for one, and then ask you how fast the other one is breaking down. So if oxygen is being produced at 6.0 times 10 to the negative 5 moles per second, so that's how much that oxygen is being produced, how much is ozone breaking down? How fast is ozone breaking down? So there is a relationship between the production and the breakdown of these two things. So let's take the reaction rate. We're going to see that up here the coefficient of the ozone is 2. So we're going to have the 2 on the bottom of the fraction that's multiplied by the concentration. Now ozone is being broken down. It is a reactant, so it's going to have a negative rate. It's actually becoming less and less and less and less. So it's not increasing, it's actually decreasing. So its rate's going to be negative. So in this case, it's going to be negative 1/2 times whatever concentration of ozone it is. Now this is what we're actually trying to find. This one will be given to us. This is going to be equal to, there's 3 here, 3 moles, so 1/3 or 1 over 3 times the concentration of the oxygen. Now you're going to be given that in just a second and then asked to find the other. Okay, so remember, I'm solving for the concentration of the oxygen. I want to find, or ozone. I'm trying to find this. So I want to get this 2 out of the way. All right, so the 2, this is an equal sign, so it's on the bottom of 1. So if I bring it across an equal, I have to bring it to the top of the other. And so you're going to end up with 2/3 times whatever the concentration of the oxygen is. They gave you the concentration, 6.0 times 10 to the negative 5th moles per second. That's how much is being produced. It's how fast it's being produced. Well, everything else is solved. You're just going to take 2 divided by 3, multiply it by the 6.0 times 10 to the negative 5, and that's the concentration of the O3, the ozone, O3. And this O3 is going to have a negative rate because it's being broken down. Okay, so when I do that math, 2 divided by 3 times 6.02 times negative 5, I'm seeing that it's being broken down at a rate of 4.0 times 10 to the negative 5 moles per second. So in this case, I only had 2. I only had 1 reactant and 1 product. But it really doesn't matter. You can have as many as you want. They're going to be added together. Each one of these can be considered separately. So I hope this helps. Try this, and we'll try some other examples in class.